names highlighted. Apologies for hosting this introductory lecture, putting on a hate. It's a bit cold this side, so just forgive me, guys, for that. All right, so basically, without wasting much of your precious time, I'm the one who's going to take you through advanced business mathematics. So I just made a couple of slides just to give you an overview of how I deliver this course and also what to expect, right? So basically, let me share the screen here and just confirm if you manage to see something on the screen. All right. Let's see. Okay, so I'm assuming that everyone is seeing the screen. Okay, so all right, basically, so basically, advanced business statistics. So statistics, it's just the same, right? It's just the same all over the world. It doesn't change. The principles of statistics, it's all the same. So what I'm going to do is I'm just going to give you I'm just going to give you a background of what statistics is all about, right? And maybe one or two things that we're going to cover during the lectures that we're going to have, right, for those that are going to come in. So basically, when you're talking about business statistics, it's all about numbers, right? So especially people that are in management, whenever you see a figure, when you're dealing with whatever you're dealing, as long as it's a figure, right? That's statistics. So be it you're talking about income, talking about profit, turnover, levels of production. These days, they're now some businesses are going as far as forecasting, right? Having what they call forecasting methods. It's actually a separate chapter in your module, right? Where they are using some modules just to forecast if they're going to make a profit, if they're going to make a loss, right? So it's all statistics that is involved, right, in those things. So basically, what is statistics, right? Because we need to understand what we are talking about, right, before we can do whatever we are supposed to do in the course. So basically, statistics is all about gathering data. You just don't gather data because there's a reason why you're gathering data, right? So statistics it revolves around gathering data. You classify the data, you summarize the data, interpret, and then you draw conclusions from the data. So why are you drawing conclusions from the data, and why are you gathering the data in the first place? So the reason why people gather the data and to draw conclusions from the data is because they want some statistical information to support their decision making processes, right? So when a company wants to change from one strategy to another, right? They want something that maybe that can interpret results for them, right? Maybe they've changed. Let me say they've changed from one strategy to another now. So they want to see whether the new strategy is working, right? So they check the profits from the old strategy and then profits from the new strategy. Then they use statistical methods to see if there is a difference, right? They call it a significant difference, right? Statistical difference between the two strategies. So you can't make that kind of a decision with your eyes just by seeing numbers, right? Because sometimes you can see maybe 100 and then in the 98, and then you say, obviously 100 is larger than 98. So definitely this strategy with 100 is much more profitable. But yet statistics can tell you, though the numbers are different, but they are the same, right? They call it statistical, they are statistically the same, right? So sometimes our eyes can deceive us. You need statistical models to really support the decision that you are making at that particular time. So that's the reason why people gather data and draw conclusions from the data, so that it can help them when it comes to supporting the decisions that they want to make. So statistics, it facilitates the informational presentation of data to support decisions that are needed, and refers to a range of techniques and procedures for analyzing, interpreting, and displaying data in order to make decisions based on that same data, right? So now we understand what statistics is and where we can use it in terms of business. Now, the next question, the next thing that we want to talk about is the types of statistics. Now, this type of information, you will not find it in your study guide, right? Your study guide is just, it just hits the ground running. Unit 1, it starts, it starts actually with describing, the difference between a discrete data and continuous data, and then it doesn't go deep into this stuff. But like I said, this is an introductory lecture, right? Some of those units are going to delve in deeper as we go along. So types of statistics. Now, there's what we call descriptive statistics. So descriptive statistics is when we are talking about statistics that are mainly inclined to summarizing and describing the data by use of what we call frequencies, percentages, measures of central tendency, dispersion, or spread, by looking also at the shapes of distribution. So basically, when you're talking about summarizing, describing data, that's your unit 1 and unit 2 from your module, right? Where unit 1 is just giving you an introductory foundation of what they call the frequencies, right? And then also what they call the Ogive curve. Then unit 2, it starts to speak about what we call the measures of central tendency, and then dispersion spread. Then there's what we call inferential, right, statistics. Now, this type of statistics, it is used when you want to make a generalization, or when you want to infer, right, to a population, right? Whatever that you get from your statistics, you are inferring it and you are generalizing it, but you use what is called a sample to generalize it about the total population. So maybe you want to find, right? You want to generalize. Like right now, we are in the midst of a pandemic, right? And then maybe you want to check if gender-based violence, right, is increased or decreased as an effect of the lockdown rules, right? So what you do, you don't have to find each and every person who is a victim of gender-based violence, but what you just do is you just look for a sample, right? You look for a sample, you do your statistical analysis, and then you infer, you generalize it to the whole population, right? So that's where inferential statistics comes into play. Now, where statistics comes into play, right? You can't talk about statistics without talking what is called data presentation. Because remember, when you're making a decision making, you have a board. Maybe you want to suggest, right, a model, or maybe whatever decision that you want to suggest for your management. You need to have information that they can see, right? They need to see the figures. They need to see what you're talking about. So that's where the issue of data presentation comes into play. So the information obtained from a statistical analysis is meaningful to business managers only when it can be interpreted and communicated effectively and concisely, right? So it is customary to convey such information through the use of summary tables and charts. That's where now the issue of a frequency table, a histogram, right, unit 1, or an Ogive curve comes into play, right? You are trying to convey information, right, vividly, right, in a way of you're presenting it in a certain way so that people can see it. So the reason why in statistics we use tables and charts is because they are more vivid and quick to see than a written format. Right, what am I talking about? Let's look at this example here, the beauty of using tables, right? So on the left side here, right, on this left side, on this side, you can see that this is information that we're being told, right? Someone is just trying to tell us information, but I'm actually even feeling, lazy to read because there's so much things that are written there, and you won't even be sure if you can really get what the information on the left side is trying to be conveyed. But now you can see that the same information is also relayed, but in this way it is relayed through a table, right? So these two examples, they are speaking about the same thing. The left one is a written form, and then the right one, it's a table, but they're talking about the same information. They are conveying to the audience the same information. But you can come to find that when one looks at the table, they can actually have an idea of what the person is trying to talk about without even explaining. Right, you can see, okay, there are institutions, there are universities there, they are being ranked, and basically those are the number of maybe students that are enrolled in each and every university. But on the left side, you can't even see it, right, without reading. So that's the beauty of what that's the beauty of using tables when it comes to data presentation, right? So the most commonly used table when it comes to summarizing data, right, is what is called a frequency table. Now, a frequency table, it is a table that shows the number of occurrences of a variable falling into a specific range or category. Okay, let me try to explain what this means by this example. That is like I said, you won't find this in your study guide. I'm just trying to give you an overview. Right, but the frequency table, that's unit 1, is actually there, but they don't give you this information, right, that I'm giving you there. It's more like the person who made your module, they are assuming that you already know this stuff, right? So a frequency table, let's consider a group of what? A group of 47 males, right, of various ages. 12 are between 20 to 29 years of age, 13 are between 30 to 39, 7 are between 40 to 49 years of age, 8 are between 50 to what? To 59, and then the rest are between 60 to what? To 69 years of age. So basically, what we will be doing when we are creating what is called a frequency table is you are grouping the data based on a specific range. Like in this case, you are grouping people in this first scenario. Okay, let me take my pen here. So in this first scenario, right, you are grouping every person amongst the 47 males that you have chosen. You are grouping the first group based on the age 20 to 29. Then amongst the 47 males, you have to find how many people have got the age that lies within that interval. Then you come to find out that they are what? They are 12. The same thing for 30 to 39, come to find out they're 13. The same for this, 7. Same for that, it's 8. Same for that, it's 7. When you add this, they'll give you a total of what? Of 47. So what we are doing now, when you are using what is called a frequency table, you are grouping the data, right, based on a specific range or category. That's what the statement is talking about. A frequency table shows the number of occurrences of a variable falling into a specific range or category. Here we're talking about the number of males whose years lie within 20 to 29. That's what a frequency table does. So immediately now, what we can see from the frequency table, we can see that the majority of the males are young. Why? Because they are below the what? 40 years of age, which is 12 plus what? Plus 13, which is correct, right? And then most lie between 30 to 39, because that's the highest frequency, which is number 13. And then if you add those frequencies, you get the total number of males that were chosen for this study. All right, so now let's talk about what is called the cumulative frequency table, the one that you will use to construct what is called the Ogive curve, right? The Ogive curve. So we are going to talk more about it when we delve deeper into your lectures, but I'm not going to talk about much of it today, right? So all right, so So a cumulative frequency table, it is a frequency table that you have an extra, right? A frequency table from the previous example, you can see from here that it has interval and the frequency itself. But now a cumulative frequency table has got a third column where it's called cumulative frequency. So I'm going to explain how you come up with that. So here you need to pay attention, because if you don't understand what I'm saying now, it will be very hard for you to construct what is called an Ogive curve, because an Ogive curve from unit 1, it has to be derived from this cumulative frequency table. So let's talk of this example that I think maybe can clearly outline how you can come up with what is called the cumulative frequency table that will help you to create the Ogive curve. So let's consider a class consisting of 100 students. Suppose the teacher gives the entire class a statistics test, which has a maximum mark of 100. Upon marking the scripts, which are in no order whatsoever, he puts the marks into a table as shown below. This represents raw data, since there is no set order of marks. So what happens now is the teacher, right, after taking all the after taking the marks of each and every student, he records them in no order. This is what they got, right? This is what they got. If you count here, you come to find out that there are 100. But now now we want to group now, because that data, it's ungrouped, right? The data is not grouped at all. It's totally ungrouped, right? But now we want to group it so that a certain number of occurrences of that variable, they can go within a specific category or a specific range, right? So what we do is we create intervals, right? You create an interval. In this case, they used an interval class, right? Which is a class width of what? Of 10. All right. So I want you to take note that there are 3 terms that you must understand when it comes to cumulative frequency when you're talking about an interval class. So there's what we call UCL, right? It's called upper class limit. Upper class limit, that's your highest number within that class, right? Like in this case, we have got a class of 0 to 9. So the upper class limit of this particular class is 9, right? The upper class limit for this particular class, it is 19. That is the highest number for that specific interval class, right? Then there's what we call lower class limit. Lower class limit now, that's the lowest number for that specific class. Like the first class, the lower class limit is 0. For the second class, the lower class limit is 10. Then there's what we call a class width. Now the class width, that is the range of that particular class, right? Like in this case, from 0 to 9, someone might say that it is 9. It is not 9, it is 10, right? Because if you count from 0, right? If you count including 0 up to 9, you get 10, right? So the class width here is 10. But the easiest way for you to calculate, right, the class width, what you can do is you've got 2 ways of it. You can use 2 upper class limits. You can use, let me change maybe the color of the pen here so that you understand. So you can use 2, right? 2 upper class limits of adjacent classes, right, to find the what? To find the class width. Or you can use also, right, 2 adjacent lower class limits, right? 2 lower class limits of adjacent classes, right, to find the class width. So let's start with the first one, right? So what I'm trying to say here is when we are using upper class limits, let's take this class and that class, right? So what now? What I want to do now is to find the class width. So I'll take the upper class limit for the second class, which is 19, right? And then I subtract 9 I subtract the lower upper class limit of the first class from the upper class limit of the second class. So this becomes 19 minus 9, right? Then I get what? Then I get 10, right? So now, which means now that let me see, let me take my pen here. All right. So we have used upper class limits only. Now we found that the class with this 10. Now let's try to find this. Okay, one might ask, why are we calculating the class width in the first place, right? Now, when we go to unit 2, where you are talking about the measure of dispersion, right? There are formulas that you're going to use where you are calculating a mode and median of grouped data, right? You need the class width. So you need to know how to calculate the class width. Because if you don't know how to calculate, what your lecturers will do is they will just give you the frequency table, right? And then they will just say, give us the median, give us the mode. So you need to understand how to calculate the class width. So that's why I'm taking my time to show you how to calculate what the class width. I'm not just wasting your time, right? I'm actually showing you something that we are going to implement later on when we do unit 2, right? So the first method I showed you is using the upper class limits of 2 adjacent classes, right? Where we used 19 and 9. Now, when you want to use lower class limits, in this case, now we have to take 10 and 0, right? 10 minus 0, you still get 10. So whichever classes you use that are adjacent, you still get the same answer, right? Even if we take these 2, right? If we take these 2 upper class limits, right? 79 and 69, you still get 10. Even if we choose to use what? The lower class limits, it's 70 minus 60, which is also 10. So regardless of whichever classes you take, which are adjacent to each other, right, you will still get the same class width because it's the same, it doesn't change. So I'm hoping that you really got what I am trying to say here, right? All right. So, okay. So one other thing that I wanted to highlight is my classes, when I do them, they are interactive, right? So I know maybe since it's first time, some of you might not feel comfortable asking questions. But what I do normally when we were doing these lectures is, when you don't have if you have a question regarding maybe a specific slide or whatever that I'm explaining at that particular time, you don't have to wait until the lecture is over. You can just maybe unmute yourself, or maybe just find a way of or maybe writing on the chat that you have a question if you want me to explain something again, right? So if maybe there's someone who wants, maybe who didn't understand what I was trying to say, just feel free to just highlight that you didn't understand, so that I can repeat myself again. All right. So all right. So okay. So what happens now after we have calculated the class width, right? Now we want to find what is called the cumulative frequency. So what happens now is, since we've got 100 students, now we want to group them based on the marks that they got, right? So there are students that we are assuming got marks from 0 to 9, and there are students that we are assuming got marks from 10 to 19, 20 to 29, and so forth, up until to 100, right? So now what we come to find out is that there is one student, when we go from the data that we got from the statistics test, right? We come to find out that there's one student who got a mark from 0 to 9. Then there are 2 that got marks from 10 to 19, 5 that got from 20 to 29, and so forth. So this is the frequency. Now, when we're talking about the frequency, that's the number of occurrences of that variable, right, for that specific category. Like in this case, these are the number of occurrences of the students, right, that got a category that fall in the category of 0 to 9 marks. Now, so when you add this, they must give you the total number of all the students, right? That's what that wrote the test. So you can come to find out that the majority from this frequency table, you can see that the majority of the students, they got marks from 50 to 59. So that's the beauty of using a frequency table. You can quickly see, right, where the highest frequency, the class that is the highest frequency. But now let me talk about this now, what is called the cumulative frequency. Now from unit 1, this column called frequency is the one that is used to create what is called a histogram. There's a slide later on that I'm going to explain about that, right? But I just wanted to highlight it here. So when you are asked to create a histogram, this is the column that you use. You use what is called the frequency column. But now when you are asked to create what is called the Orgaive curve, right? The Orgaive curve, if you go and check, if you go, I didn't put the slide it here, but if you go check in study module, right, under the first unit, you come to find out what they call the Orgaive curve, right? That Orgaive curve is created from this column here, what is called the cumulative frequency. So now let me try to explain how do you come up with cumulative frequency given frequency only, right? So the first cumulative frequency, you just write the first frequency as it is, right, which is 1 year and 1 year. But now going forward, what you do is the cumulative frequency for the second class. What you do is you say the frequency of that class plus the cumulative frequency of the previous class, which is 2 plus 1, and then you get what? You get 3, right? Now, the cumulative frequency of the third class, it is the frequency of that particular class plus the cumulative frequency of the previous class, which is 3 plus 5, that gives you 8, right? Which is the same thing again for the fourth class. You say that the frequency of this class plus the cumulative frequency of the other class, right? And then you get what? You get 14, right? So that's how you get all this cumulative frequency up until you get 100, because there are 100 students that wrote the test. So when you plot this, later on I'll show you how to do it with Excel, right? When you just punch this in Excel to create a graph, it will form what is called an Orgaive curve. That's what the Orgaive curve is, right? The Orgaive curve is created from what is called the cumulative frequency. All right, excuse me. So, all right, so we are done with this slide, right? So I hope most of you guys, you understood, all right, what I was trying to explain from this slide was that's your unit 1, right? That's your unit 1, and that's your unit 2. Because if you don't know how to calculate class width, you're going to have problems in attempting median and mode in unit 2. And if you don't understand how to create a cumulative frequency, right, you have problems in what in creating what is called an Orgaive curve. All right, so now apart from tables, we have what is called graphs and charts, right? So you use a chart, right, when you want to show a dominant feature or a trend, right? Let me show you from this example. So we have we actually have got 2 ways of presenting data, right? The left one here, it is a table, and then the one on the right is actually a line graph. But now it's the same information that's being conveyed, but you can actually see that from the data on the left, we are being told that there is a year and the profit for that particular year, right? But you can't tell the trend. You can tell, of course, that the figures are different, right? But you can't tell necessarily the trend, right? The trend that these profits are following. Maybe if you look closely, that's when you can see, oh, these numbers might be what? Might be flowing. But what if it's fluctuating? Right, so you need for you now to see a certain trend or a dominant feature from the data that you have. That's when you employ what are called graphs. Like on the right side there, you can see that the same data is being displayed in form of a graph. We can clearly see that there's been a loss, right, for the past few years from the company, right? But you can't tell it from the information that is on the left side. So like so each and every method of presenting data, it has got its own pros and cons depending on what you want to convey to your audience. If you want people just to see, like maybe you want to show them like the highest frequencies and so forth, you can use your frequency table. But when you want to send a message that shows a dominant feature or a trend, that it will be much more useful if you employ charts and graphs. So there are other things that they call bar graphs, right? Bar graphs, you're just that's it's the same information, but we are no longer using a table or a graph. We are using what is called a bar graph, right? It's called a bar graph because the value, the frequency itself is represented by a bar, right? Then there's what we call pie charts. I know maybe in this your course, maybe you can skip this one since it's not there. But in a nutshell, pie charts are just used to express proportions, right? Proportions of a certain value being compared to the whole of the amount. Like in this case, this were 3 children that were given money to spend, right? One was given 120, the other was given 80, the other one was given 50. So the elder one is the one that has the gray part, right? Because 120 over the total amount, you get this proportion, right? 80 over the total amount, you get this, and then 50 over the total amount, you get this. So when you just want to show the proportion of maybe for those, maybe when you do dissertations, pie charts come in handy when you want to show maybe the percentage of when you are asking about the gender, right? The gender of your participants, right? That's where pie charts come in handy. You just show that 50% or maybe 37% were male and then the rest were female. So the best way to convey that type of information, you use pie charts, right? So like I said, it depends with the type of information that you want to convey. That's when you choose the best method of data presentation that works well for you. Then there is the histogram that I was talking about, right? So a histogram is more like a bar graph, but it's a special type of a bar graph, right? It's not like your normal bar graph, because you can see obviously there are bars there, but it's not your normal bar graph. It's a histogram. It is a graph that displays what is called the frequency distribution. Now, if you backtrack a little bit, you come to find out that when we were talking about the frequency table, we had a column called the frequency, right? Where you are grouping each and every variable based on the specific category that they fall into, right? So you come to find out that those frequency, if you plot what is called a bar graph based on those frequency, it's called a histogram, right? So a histogram, that is a graphic display of what? Of frequency distribution. So now, basically, I've managed to put unit 1 in a nutshell, right? In a nutshell, just for you to have a test and an overview of how they came about. Because if I'm not mistaken, they didn't really go deep like what I did this evening. They just start, just talking about a frequency table. They didn't explain to you what is it, right? They talk about Ogai's curve. They didn't explain what it was. Yes, it looks like yes, Lisego, you can go ahead if you have a question. If you do, you can just go ahead and type in the chat, or maybe you can unmute yourself if you feel comfortable. You can. Oh, okay. Yeah. James is supposed to share this recording in the group, right? So don't worry. He is going to share it in the group. If he doesn't, you can just remind him in the group. All right. So now let me. So now I have, like I said, I've just tried to give you an overview of Unit 1, but when we proceed from the next lecture, I'm just going to delve in deeper now into examples of how maybe we look for an example where you are given, a frequency table, and then how do we really calculate the cumulative frequency using Excel, and how do we draw the Orgreave curve using Excel, and also how do you draw what a histogram, right? And then to make some calculations. I see that in Unit 1, there are some calculations about percentiles, right? When you are talking about the Orgreave curve. So that's the other thing that we'll look deeper, but in the next lecture, right? Now, let me just give you an overview of measures of central tendencies, which is Unit 2, right? And then maybe I'll just do an example of one or two things, of mathematical example of how like the mathematics part of the statistics is like, right? Because statistics is all about workings. So I just wanted the Unit 1 is more like theoretical, right? Unit 2 now, that's when you start to do the mathematical part of it. So I just wanted to show you how you do the mathematical part of it. So measures of central tendencies. When we're talking about this type of descriptive statistics, right? It is a single value that attempts to describe a set of data, right? So it describes a set of data by identifying the central position within that set of data. So a very, very, very common, right, measure of central tendency is what we call average, which some people call the mean. We actually call it mean, right, when we are dealing in statistics, but it's average. When you're saying what was the average mark, right, of the class, right, that is a central position, right, that can describe the set of data. Like you just say, the average of the mark that the students got was around 70. So it means that roughly everyone got 70. So the marks of everyone is being described by a single value, right? That's what we are talking about when we are talking about measures of central tendency. So they will help you find the middle of the data, right? Like when you want to separate data into two halves, the middle part of it, or it can also help you to find what is called the average, which is the mean, right? So the three commonly used numerical measures of central tendencies that we are going to mainly look that we are going to talk about in this module. It will be the mean, which is basically your average, the median, which is basically the value that separates what your data into two halves, right? And then there's what we call the model. All right, so before we proceed, there's a foundation that I want to lay, because if you fail to understand this, it means that Unit 2, you will not be able to answer it, right? So this is very, 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 very critical. So I really need your undivided attention here, because for you to really understand how to attempt answering questions based on Unit 2, you need to understand this slide, right? So this slide, basically what you need to understand is when you gather data, when you have data before you, you might have two types of data, right? So the first type of data that you have is what they call ungrouped data, or what they call raw data, right? So when we're talking about raw or ungrouped data, that is the data that you get when you first gather from an experiment. Like if we backtrack a little bit, you come to find out that there's an example that I gave you of a statistical test that was written by 100 students, right? And then there was a table that the teacher wrote, not the frequency table, but it was just maybe a recording table. So that type of information is called raw data, because you haven't sorted it in any way. You haven't even grouped it as yet. You just collected it as it is, right? You collect that this one got this mark, this one got this mark. You haven't even done anything as yet. It's not sorted, it's not grouped. So that's why it's called ungrouped or raw data, right? Now, the reason why I'm taking my time to explain this is because they are the methods, right, you will use to calculate the mean, the mode, and the median of grouped data, right, are different from the formulas that you're going to use to calculate mean, mode, and median for grouped data. So you must understand, because when your lecturer is giving you an exam or an assignment, they will not tell you that the data that you have given you is ungrouped. The data that you have given you is grouped. You must be able to know it yourself. So when you realize that this data that I've been given is ungrouped, then immediately you know that the formulas that I'm going to use, they are formulas for ungrouped data, right? If you are given grouped data, then it means that the formulas that you're going to use are formulas for grouped data. So that's the reason why I'm taking my time to explain this, because if you miss it, when a question comes, you might not even know which formula to use, right? So you must be able to understand, is it to differentiate whether it is grouped data or ungrouped data. Now, what is grouped data? Grouped data now, that's data that is given in intervals. So when your lecturer gives you a frequency table, data that is within a frequency table, then that is grouped data. You have grouped it based on specific categories in specific ranges, right? In data that has been bundled together in categories. That's where the issue of frequency tables and histograms comes into play. So if you are given data which is not a frequency table, that is ungrouped data, right? If you are given data that is displayed as a frequency table, then that type of data is grouped data. That's when now you come into, if it is ungrouped data now, that's when you start to use this formula. You see, because like I said, mean, mode, and median for ungrouped data, the formulas are different from grouped data, right? That's why I took my time to really try to explain that, right? So now let's start by explaining how to calculate what? The mean for ungrouped data, right? So ungrouped data, like in this case, you're just given that these are the marks of that were received by 7 students when they were writing a spelling test. You can see that this data is not even grouped in whatsoever way, right? It's not even grouped at all. It's just data that have been given. It's not sorted, it's not grouped, right? It's just listed as individual data points. So what you do now is we have identified that this type of data is ungrouped. So now to calculate the mean, you use this formula there, right? Maybe let me zoom in a little bit on that. Okay, what happened? All right. Let me just zoom in a little bit there. All right. So mean, the mean basically, it is the sum of all the observations divided by the number of observations, right? So basically what it means is you're going to add all these marks, right? And then you divide by the number of people that wrote the test, which are 7. So you come to find out that the mean is 66.86. So basically we are saying that each student, right, basically roughly they got 66.7%, right? So the marks of 7 students are being explained by one central value. That's what measures of central tendencies do, right? So let's talk about what is called the median for ungrouped data, right? So the median, it is the middle number of an unordered set of data. It divides an ordered set of data values into equal halves. So it is a value that you calculate, right? After calculating it, it is a value that separates your data into 2 equal halves. All right, so there are a couple of steps that you have to go through in order for you to calculate what is called the median for ungrouped data. So the first thing is, when you are given your data that is still raw, what you need to do is you need to arrange them in ascending order, right? Don't worry, we're going to do an example later on, right, to show you that. So the first thing, before you can find the median, you can't find the median without first arranging your data values in ascending order. When you are saying ascending order, you start from the least value to the maximum value, right? So you rearrange them. You'll be given the data in a certain format, but you have to rearrange it in ascending order. When you do that now, what you need to do is identifying the middle position now differs depending on the number of data values that you've been given, right? So if your n, which is your number of data values, is odd, like in this case, there were 7 students that wrote a spelling test, then you have to use this formula, right? Where you are saying n plus 1, right? You are finding the position of the data set. That is the position of the median value, right? So in this case, it will be 7 plus 1, which is what? Which is 8. 8 divided by 2, which is 4. So the value on the 4th position, after you have rearranged it in ascending order, right? That value on the 4th position is the value that separates the data into 2 equal halves. So that is your median value, right? Basically, that's what it means. Now, if n is even, where n is not odd, right? Like in this case, let's assume that maybe there were 8 students that wrote the spelling test. Then you come to find out that you have to first find the n over 2 position, which is 8 over 2, which gives you 4. So when you get the 4th position, then the next position now, which is the 5th, right? You take the value on the 4th position and the value on the 5th position, you add them together, and then you find the average. The average that you find there, that will be the median. So let me do an example here, so that you understand what I'm saying. But sometimes when you're explaining with words, people might not get what you're saying, right? So let's look at this example. Remember, like I said, this stuff you won't get it in your module. It's just for introductory purposes, so that at least when we start the course, at least you guys will be on the same page, right? So now find the median number of cars, right, sold per month by a dealer over the past 9 months based on the following monthly sales figures. So the first thing is we're just given data is raw. They just took the number of sales, right, for n9 consecutive months, right? Now, the first thing for us, when we want to find the median, we need to order the data first in ascending order. That's why now here in this case, this is data that is raw, unordered. But this data now, you can see that you're starting from the lowest value. Here we're starting at 27, 38, 12. It wasn't in a particular order, but now you can see that it is following in ascending order up until you get to 42, right? 42. And then now what you come to find now is since our data is odd, we use that formula n plus 1 over 2, which is 9 plus 1 over 2, which gives us 5. So what you do is you look for the 5th position. So this is 1, 2, 3, 4, 5. So when you come here now, the value on the 5th position, which is 34, you can see that this position, it divides the data into 2 equal halves. You can see that the data values on the right side is 1, 2, 3, 4. Data on the left side, 1, 2, 3, 4. So this value is called the median because it is the value that divides the data into 2 equal halves. That's where it comes from. So the median now, it is the value on the 5th position, which is 34. So what does that mean? It means that this means that there were 4 months when car sales were below 34 cars per month, and 4 months where car sales were above 34 cars per month. In this case now, they are trying to interpret, right, the information based on the value that they got, right? Because they are saying, since we have divided, we have rearranged the data into ascending order. Now we can tell you that based on the median value that we got, there are 4 months where we got sales that are less than 34, and then we've got 4 months also that we got sales above 34. So basically, that's where the issue of the median comes into play. right? Now, when it is now the data set values, if they are now even, you do the same thing again, right? You rearrange your data. But then now what you have to do is you have to find the n over 2 position, which is 5, right? So what you do now when you find your fifth value, which is this, but you can't say now this is your median, because you can see that 1, 2, 3, 4 on the left side, 1, 2, 3, 4, 5 on the what? On the right side. So this is not the median. So that's why we said when you've managed to find the n over 2 position, what you need to do is you take the next position, right? Which is this position, right? When you take these two values, this value and this value, when you find the average of it, right? Which is 27 plus 34 over 2, you get what? 30.5. So 30.5 is somewhere here, right? 30.5, which is somewhere here. So 30.5 is your median. So what does it mean? It means that any values, there are 5 values now above this value, and there are 5 values below this value, right? Which is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this value now, it becomes your median. That's the value that separates your data into equal halves. So this means that there are 5 months where car sales were below 30.5 cars per month, and 5 months where car sales were above 30.5 cars per month. So basically, that's the median, right? Then the last one that we're going to look at because of our time is what is the mode for ungrouped data. This is very easy now because the mode for ungrouped data, this is the most frequently occurring score, or the number that occurs the most, or the number that is repeated the most number of times. Like in this case, these are what are scores, right, of that test. We come to find out that 64 is the mode because that's the number that is repeated the most times, right? So maybe if there was another number also that was maybe 85 was repeated twice, and then 64 was repeated 3 times, right? Then 64 still will be the mode because it has to be the number that is repeated the most frequent occurring number, not only the frequent, but the most frequent occurring number. So it must be the number that is repeated the most, right? So that is your mean, mode, median for ungrouped data. Now, just to show you something, when I'm not going to go into this, but I want to show you where the issue of the class interval comes into play when you are calculating the median for ungrouped data. You can see that there's a value called class width, the one that I was trying to show you from the cumulative frequency table, right? So that's what I was trying to show you, that, you know, I'm not just showing you how to calculate the class width because you are going to use it later on. But like I said, today we're not going to delve into the other part. So guys, thank you very much for your time and coming in just to check on how we will be doing our lectures. So I don't know if there are any person who has a question before I hand back this time to James. All right, so I'm assuming that the silence is showing that everything is fine. James, over to you.
Okay. Thank you, Mr. Swanda, for the work that you've done. I'm sure the students appreciate it very, very much. Okay, guys, I'm going to post the link to the video in the group in case you want to revise some of the content that has been covered. Then if you've got any questions, you are free to ask them in the group so that maybe I can respond to them, or I can forward them to our tutor over here to respond to us. Then in terms of our lectures, for us to able to continue with Mr. Kudaswanda, there is a token payment that you need to make for 650 Rand for the whole semester for this specific module. The 650 Rand will cover the tutoring, will cover access to the videos, will also cover guidance in terms of the assignment that you're going to read. So he's going to go through the assignment with you guys, and also past exam papers. We will go through some past exam papers, provide answers for you, see what you would have done to get good marks in the specific exam. So if there are any questions, please ask them in the group. I will forward them to our tutor. But the 650 Rand, I'll post my banking details in the group. I'll post the link to the video, and I'll just post a summary of what that 650 Rand will cover. Then for those of you that are interested, you can send through the finances, and then we can start the classes. I was hoping that we will be able to start the classes as early as next week, right? But it all depends on the payments that I receive this week. But if you guys delay payments, then maybe we might have to start later during the week, maybe the second week of August or so. But we want to start as soon as possible so that we can quickly go through the study module. Are there any questions for me before we end this lecture?
No questions, James. Thank you very much. Thank you, Kuda.
All right, thank you. I trust you're all happy. I'll share the lecture in the group.